Nice to meet you, I'm Khatar and watching my YouTube channel School of Advanced Chemistry. I'm going to explain how to remember, how to memorize test for anions and cation for IGCSE and O levels. If you're going to do the practice in this way, in this tree diagram, then you can learn these tests in very short time interval. Just have a look. For example, I'm having different sort of ions, positive ion. I'm going to talk about first of all cation. Let's suppose I'm going to have different type of cations, positive ions. Number one, for example, I'm having aluminium 3 positive ion in this beaker, in this jar, in this container, NH4 positive ion, calcium 2 positive ion, and zinc 2 positive ion, Cr 3 positive, chromium 3 positive ion, iron 2 positive ion, iron 3 positive ion, and copper 2 positive ion. So overall, you are going to have total 8 positive ions, cations for testing. Now, the first step is I'm going to add, let's suppose, few drop of sodium hydroxide. Few drops of sodium hydroxide, and here are basically two possibilities. Number one, there is no precipitate seen and precipitate seen. There are two basic major main possibilities are there. In case of precipitate, we are going to check it further. What are the color of precipitate? Precipitate may be colored or may be white. So there are two type of precipitate may be if there is the presence of precipitate. In case of white precipitate, it may be aluminium positive ion, it may be calcium 2 positive ion, it may be zinc 2 positive ion. So first of all, on addition of few drop of NaOH, there may be the presence of AlOH thrice, that is the formula of that precipitate, or ZnOH twice, that is the precipitate of zinc. And similarly, there may be the formation of calcium hydroxide, CaOH twice, for the white precipitate, as a white precipitate of the calcium. So in case of white precipitate, these three nominees may be present. In case of colored precipitate, these are the transition elements over here, and chromium, iron 2, iron 3, copper 2 positive ion. So number one, I am going to write Cu2 positive ion, and it may be blue in color. Blue precipitate will be there in case of copper 2 positive ion. Now, in case of iron Fe2 positive ion, the color will be green over here, green precipitate, or sometimes we call it dirty green precipitate. So green precipitate will be there. In case of iron 3 positive ion, there are a reddish brown precipitate or a red brown precipitate. And the last one, the fourth one, is chromium once again, and it is going to have basically Cr3 positive ion if present. Then the precipitate form, that will be the color of green precipitate. Green precipitate. This copper is also said to be blue precipitate, the precipitate of this copper, or it may be said to be, or it may known as light blue precipitate. So that is the first step basically. This is the first step in which you are going to add a few drop of NaOH. Let's suppose there is the formation of these type of cations, 8 type of cations may be present, and you will see that In case of colored precipitates, in case of colored precipitate, the precipitate of copper 2 positive ion is light blue in color. In case of colored precipitate, number one, if copper 2 positive ion is present in the precipitate, this solid, this precipitate will be of light blue in color. If there is iron 2 positive ion in the precipitate, or the precipitate of iron 2 positive ion will be green precipitate. Green precipitate. In case of iron 3 positive ion, the color of its precipitate is red brown. Red brown precipitate. And the last one is chromium 3 positive ion, and its color will be the green again, like Fe2 positive ion precipitate. So these are the basic major main observations if the precipitate is supposed to be formed in this case. Now only one positive ion is left behind, that is this one, ammonium ion. So if no precipitate, then there will be the possibility of NH4 positive ion. As you have added the few drop of NaOH and there is no precipitate, then there is a possibility of presence of NH4 positive. If you are going to heat it further, if you are going to heat it, if you are going to warm it, then there will be the expulsion of ammonia gas. Then ammonia gas will be produced that turn a red litmus paper blue. So it is confirmed that if you are going to add few drop of NaOH into any solution, there is no precipitate, and then you are going to heat it and a gas is going to be formed, is going to be observed, and that gas is changing red litmus paper blue. It is confirmed that this ammonia gas and it is being formed from ammonium ion. So in this case, in fact, ammonium positive ion is present. Now come to the next stage of addition of sodium hydroxide. In case of in next phase or next state, basically, if I'm going to add excess sodium hydroxide, in this phase, same is the case in white precipitate, we are also supposed to add excess sodium hydroxide. So what is supposed to be formed? Number one, in case of white precipitate, there is again two options basically. There will be some soluble and some precipitate will remain insoluble. There is only one that is going to be remain insoluble, that is calcium hydroxide, the precipitate of calcium ion. It will remain insoluble. In case of these two above two written precipitate, aluminium 3 positive ion will be soluble in form of aqueous, you can write it in form of aqueous, and zinc 2 positive ion precipitate will also be soluble into the excess sodium hydroxide. So if you are going to add excess sodium hydroxide into the white precipitate, only calcium hydroxide is not going to be insoluble. Rest of the two ions are going to be soluble. Now come towards this colored precipitate. Again, there are the similar situation. Here are two type of observation, soluble and insoluble. In this case, basically, two type of precipitate are going to be soluble. So once again, soluble and insoluble. Here, in case of excess sodium hydroxide, the chromium, chromium 3 positive ion, that was green precipitate or dirty green precipitate, in fact, is going to be the soluble into that compound. So in this case, chromium 3 positive ion precipitate, that was green precipitate, it is going to be soluble. So chromium 3 positive aqueous will be formed. Other all precipitate that will remain insoluble. And other all precipitate will remain insoluble. Copper 2 positive ion will remain as a hydroxide, insoluble. Similarly, FeOH twice, iron 2 positive ion will remain, precipitate will remain insoluble, and FeOH thrice, iron 3 ion precipitate will also remain insoluble. So upon addition of excess sodium hydroxide, 3 precipitate will remain insoluble, only 1 be the soluble. In case of white precipitates, basically only 1 is insoluble and these 2 are going to be solubilized themselves. So that scheme holds good for the addition of sodium hydroxide. Testing of cation with respect to aqueous ammonia. For example, I'm again having Cr3 positive ion, that is chromium ion, and Fe2 positive ion, iron 2 positive ion, iron 3 positive ion, and copper 2 positive ion. All these ions are called transition metal ion. So number one, where there are these transition metal ion, there is a solution. Where there are transition metal ion, their solution will be colored. Other ions are white ions, are non-transition metal ion, aluminium positive ion, and calcium 2 positive ion, and zinc 2 positive ion. Now this time I'm not going to write ammonium ion, because if you are going to add ammonia, then ammonium ion cannot be detected, as we are going to add it ourselves. So here are basically 3 non-transition metal ion. Come toward the same first step. I'm going to add few drop of aqueous ammonia, NH3. Again, there are 2 routes, no precipitate formed and precipitate formed. In case of precipitate, further 2 divisions, colored precipitate and white precipitate. In this case, no precipitate is for calcium. Calcium 2 positive ion is not going to give any observation or precipitate. No precipitate or very slight white precipitate. Slight white precipitate. So in fact, calcium 2 positive ion is not going to give any sort of observation with aqueous ammonia. Now the remaining ions, non-transition metal ions, are over here. Aluminium ion, aluminium 3 positive ion, it will make aluminium hydroxide in few drops, and same as the case zinc 2 positive ion, it will make zinc hydroxide as a white precipitate. So these are the formulae of these precipitate, these solid. So upon addition of small amount of aqueous ammonia, two white precipitates are initially formed. In case of color compartment, copper 2 positive ion gives copper hydroxide as a pale blue precipitate. Then iron 2 positive ion gives iron hydroxide as a pale blue precipitate. As green precipitate. In case of iron 3 positive ion, there is formation of Fe3OH thrice, red brown precipitate. And finally, in case of chromium 3 positive ion is going to make chromium hydroxide as a green precipitate. So these observations are pretty similar as that you have seen upon the addition of few drop of aqueous sodium hydroxide. So almost the first step is same. Now I am going to add excess aqueous ammonia. Excess aqueous ammonia in both type of precipitates. Excess aqueous ammonia. In this case, in first case where there are the two white precipitates, aluminum hydroxide and zinc hydroxide, again two situations arise. Number one, insoluble precipitate and soluble precipitate. In this case, the insoluble is aluminum one. So aluminum precipitate, white precipitate will remain insoluble. It will not dissolve. And in case of this one, zinc will make zinc 2 positive aqueous ion solution. Zinc precipitate will be soluble. And the precipitate will be soluble plus colorless solution is formed, as this one is a non-transition metal ion. Come toward this one, there are 4 colored precipitates. Upon addition of excess ammonia into them, only one of the precipitate is going to be dissolved or soluble. So yes, you can say again soluble, and one root is insoluble. And the soluble this time is for copper NH342 positive ion. It is not necessary to memorize this formula, but the copper solid precipitate, solid copper is going to dissolve into excess ammonia, giving deep blue solution. In case of insoluble, there will be Fe2 positive ion precipitate, green precipitate, iron hydroxide, same is the case FeOH thrice, iron hydroxide brown precipitate will remain insoluble, and similarly the chromium precipitate will also remain insoluble. So only copper's precipitate, pale blue precipitate will be dissolved and making the deep blue solution, turning solution deep blue. So up till now you can see that there is tips or trick, you can say white precipitate of zinc metal ions are soluble in both excess. I mean in excess of NaOH. Again, similarly in excess Na3 aqueous. So basically we are we use two type of solutions or two type of the reagents, sodium hydroxide and aqueous ammonia, to identify the cations, metallic positive ion and ammonium ion as well. Now it's turn for the next, that is test for anions. So tests for anions, negative ions. Basically, I'm going to write the list of overall negative ion as far as O-levels chemistry syllabus is concerned. The first portion is of halide ion, Cl negative ion, Br negative ion, and I negative ion. Next one is sulfur oxide ion, I mean SO3 sulfide ion, and sulfate ion as SO4 2 negative ion. The next one is nitrate ion, NO3 1 negative ion, and the last one is carbonate ion, CO3 2 negative ion. So halide ions are detected with the help of aqueous silver nitrate. But in first step number 1, you can say, we add dilute nitric acid in almost all these sample of anions except nitrate ion. So the first step is to add dilute HNO3. The basic function of addition of this HNO3 is the removal of any carbonate ion, CO3 2 negative ion, that may be present and may affect the, that may interfere our result, and that may also going to show the precipitate. So the first step is to remove the presence of carbonate ion, and that is done with the help of nitric acid. So the first step is, in most of the cases except nitrate, the first step is the addition of HNO3. The step 2, for halide ions, we are going to add aqueous silver nitrate solution. Then we will check the color of precipitate. In case of Cl negative ion, white precipitate is formed. In case of Br negative ion, cream precipitate is formed. In case of I negative ion, upon addition of silver nitrate, yellow precipitate is formed. So silver nitrate is a specific reagent that is used to detect the presence of halide ion. So step 1 to add dilute nitric acid, then step 2 add silver nitrate solution of the silver nitrate, and then check the color of the precipitate. Come towards the identification of SO3 and SO4 negative ion. In case of SO4 2 negative ion, basically it is quite simple, you can say. Step 1 is similar. Step 1, add dilute nitric acid, HNO3, and step 2, add aqueous barium nitrate, BaNO3 twice. So upon addition of this aqueous barium nitrate, white precipitate will form. that is of barium sulfate, a famous white insoluble solid. So in this case, if the SO4 negative ion is present, then upon addition of barium nitrate after the addition of HNO3, there is the formation of white precipitate. So that is the conformation of sulfate ion. Come towards for the test for the SO3 negative ion sulfite ion. It is called sulfite ion. In this case, we are going to use a different method, you can say. We are going to add, in step 1, you can say, in first step, we are going to add acidified KMnO4. And you know the color of KMnO4 is purple. Its color is purple. And step 2 is the observation. The color of purple KMnO4 will change to the colorless. So the color of these KMnO4 solution or this KMnO4 solution will be colorless or will be destroyed. So if this is so, yes, sulfite ions are also present. In case of the next one is nitrate ion, NO3 negative ion. In this case, there is no need to add nitric acid. There must not be added that acid, nitric acid. So number 1, we are going to add aqueous NaOH plus solid aluminum metal foil. Then we are going to heat. So there are basically two main reagents, and one is the condition heat. If there is the formation of a gas, that is in fact ammonia gas, that turns a red litmus paper blue, that turns red litmus to blue. So that is ammonia gas. So if the nitrate ions are present, then upon addition of aqueous sodium hydroxide, aluminum solid foil, and heating the mixture, a gas is supposed to be formed, a gas is observed that is formed. That is ammonia. How to check the ammonia? We will introduce the moist, damp, red litmus paper, and it will turn the color of red litmus paper blue. So it is confirmed that the gas is ammonia, and it is also confirmed that nitrate ions are present. The last one negative ion is carbonate ion, CO3 negative ion. Carbonate ions are very much simple to diagnose. Just in single step, if you are going to add dilute nitric acid, then effervescence is observed. Then effervescence is observed, or you can say the fizzing is observed. The next, you can also confirm it. Why the fizzing is going to be observed? Because there is formation of CO2 gas, and CO2 gas, when you are going to pass this CO2 gas through a lime water solution, for example, this is the lime water, and I am going to pass this gas through lime water, and this passage and this, passing this gas through this lime water, it will turn lime water milky. So it will turn lime water milky. CO2 will turn lime water milky. That is the test for the CO2 gas. And now the next thing is how to perform a flame test. How to perform a flame test. Number one, basically we should adjust blue flame of the burner. Number one, adjust blue flame of burner. Number two, take a clean metal wire and dip into the solution that is to be examined. So, number one, set your flame in blue color of the burner, then take a clean metal wire and dip into the solution through which we are going to find the, or we are going to identify the metal line. The third one, the third step is note or observe the change in color of flame. Note the change in color of flame, and then you will going to match with the table which one the color of flame is this one and which one the color of new flame is this one. So in this way, these are the basically three major steps that you can carry out the flame test. So in this way, you can carry out the flame test through these basic three steps. So these are the basic steps that you will have to write in your ATP question if they are asking about the flame test, or in your P2 questions. And that's all about today. Thank you very much. Have a nice day. Please subscribe my channel, hit the bell icon and share it with your friends. Thank you. Thank you very much. Have a nice day.